All right, so this week is all about the different libraries in Python to help us facilitate automation. This includes automating data analysis with the matplotlib package, networking with the nmap module that we'll download and utilize, automating actual computer operations with the OS library, and then we are going to put it all together with the PyInstaller module. Now, let me read from you a little bit from the notes. Actually, I'm going to provide to you. Looking at this, please note that Python, and I'm just reading this right from page 1 of the course notes that I'm going to upload and require everyone to read. So, as it says, Python is not all that unique in the regard of the fact that your skills as a developer comes down to the ability to craft programs, scripts essentially that make the lives of our respective users a lot easier. And the example that this week's notes has is to create a program that, for example, archives all files of a type or a certain size, or to develop ways to process generated files from an ERP system into a database automatically. So the possibilities of what we can do to make people's lives easier are literally endless. Okay. The good news is that the concepts we cover will vary in their applicability this week. As it says, there are a vast number of third-party library modules available for our language. Python is not all that unique in that regard. Other languages such as Java and PHP offer similar tool sets. So yes, in other languages there are libraries for matplotlib. There's libraries for all these other things. But the availability is one of the reasons that Python and other languages like it see such widespread adoption. Your author uses the term batteries included to describe the phenomenon of the fact that Python has the ability, much like other languages, to grab these other libraries and do something wonderful with your application. So the quote-unquote everything you need here is right out of the box. The hardest part is finding out how do you get into the box when it comes to these. So the course notes this week provides to you some detailed information regarding that. So this week I want everyone to have fun and go for it. The sky is the limit. All right, this week we are going to actually have some fun, like I just said, using the different libraries and modules that Python has in store for us. So some of the things we're going to be talking about: matplotlib, which we can do graphs with. We're going to take a look at the pickle module, which enables us to have what we call persistent data. Persistent data is data that actually lasts after the program is closed. So, for example, in the past, we have worked on programs that generate a collection, like let's say user choices or decisions, or even randomized decisions. And maybe it gets collected in a list or a dictionary or a tuple or something like that. However, this time, this information will be collected in a program outside the local program, and so it can be referenced to after the program is opened up again. So we will see the power of this as the week progresses. Finally, we have the OS. My computer did something. I had to make an adjustment. The OS module, and that enables us to actually control our computer. Now, using the OS module as we will be doing this week, I want to impress on everyone. I want you to use your virtual OS only. Really, I want you to use your virtualized operating system using all these modules here, because I really don't want you to mess up your host computer, because, frankly, I'm not going to, in the university does not want to be held, responsible for what happens happens to your OS. So for this reason, if you break your virtualized OS, I mean, it's just treated as another app on your computer. So all you have to do is, delete the app and then install it again. It's not even a big deal. But you can't say that it's just as, meaningless if you jeopardize your whole entire host operating system. That might be a disaster. Finally, we'll talk about PyInstaller. That's when we can take any program and then essentially turn it into an executable file. That way you can just send the executable file, and you don't have to worry about the recipient having Python installed or a particular module installed, or maybe they'll have the wrong version of either Python or a module installed. So you do not remember, the apps that you're creating are for end users only, and end users come from all walks of life. I mean, it might be possible that, people in my generation or even older do not even own a computer, let alone, a computer that's powerful enough to run all this. But assuming they have a decent PC or computer, you want them to be able to run your application without worrying or being concerned with, downloading and installing Python and an IDE and all of that themselves. You want them just to double click and run the application. Finally, if we have time, we may or may not have time this week, we will run through the Nmap application. So Nmap is a great way, it's a great networking discovery tool. So what it discovers, essentially, one of the many things it discovers is port numbers and how you might even, potentially exploit not only exploit a remote system, but maybe your own system. If you run an Nmap on your own system, maybe you can discover you had open ports that you didn't realize were open. And remember, every open port is an opportunity for exploitation. Okay, and again, I only want you should be using, at this point in the class, you should be utilizing virtual OSs only. All right, what exactly is Matplotlib? Well, it is a graphical tool. It's a way to make basically graphs. As it says, a powerful plotting library for Python. And just to show you how powerful it is, you can create this graph with this little bit of code. So let me give everyone an example right here. Let me type clear and let me just run this. And before I run it, let me stream it so you can see what is going on. And look at this. It's just the first thing we do is we import the module, Matplotlib module, and we're importing it as PLT. So when we go ahead and call the matplotlib.pyplot, which is a method of Matplotlib, we just are encapsulating it in one variable. So we run it as PLT. This could be really anything. And this now is the variable that represents this matplotlib.pyplot module. And we can then say, okay, plot PLT dot, and then this is the command or method that we run, plot. And what are we plotting? We are plotting this list right here of things, of plots. 1, 2, 3, 4, 8, 10. And the Y label shows us what we want the Y label to be, and that's test. And the .show command actually basically paints it onto the screen or shows it. So this is what it looks like here. Let me move it over, and we can see the word test. I'm just dragging it onto the screen so you can see. So the Y label is test. We can also have an X label right here if we wanted to, but we can see that these numbers right here, 1, 2, 3, 4, 5, they correspond, the index of them corresponds to the Y value. So that's index 0, 1, 2, 3, 4, 5. So for example, the fifth number, which is 10, corresponds to the 10 point on the Y graph, and then the fourth point, which is basically the fifth point in terms of starting from 1, but starting from 0, it's the fourth point. Number 4 corresponds to 8, and so on and so forth. So I can just exit this, and we can change it actually to whatever we want. So let me do sudo vim chartmaker.py, and we can just say, we can make more of a straight line. So we can say 1 and then 2, and then that's 2, and then we can bump it all the way up. We can say that could be 10 and this could be 20. Let's see what effect this has, and we can see what effect that it has on the graph itself. So we can again cat it out, and we can and basically you saw the difference that it made. All right, installing matplotlib, that's another question you might have. Now that I've shown you how good matplotlib is and how simple it is to use, how can we install it? Does it come with Python already installed? And the answer is no. So in order to install it, at least on a Linux system that you already are running Python 3 on, this is the command to install it: sudo apt install python 3-matplotlib. Now there's other ways to install it, but this is the way that I feel works the best on a Linux system. Here is yet another matplotlib example. Again, we import matplotlib as PLT. This time we have created a list right here, and this is basically farming activity over basically the number of crops that are basically outputted, or the amount of crops that you get. And this is like the inverse 1 over a certain number. So we're going the range of 0, starting at 0, going all the way to 17 per the parameters of the range command right here. So for I in range 1 through 18. And I just wanted to clarify that the first thing in the for loop that happens is we are ensuring that I is an integer, and then we say x is equal to 1 over I, and then we are simply appending x to this empty list, fa over fn, and that is what we're plotting, the result of the appending of this 1 over 0, 1 over 1, 1 over 2, all the way to and including 1 over 17. And it's going to get you this asymptote in relationship right here that you see here, and we see that the x label is fa over n and the y label is farming density. So just to show you that we can actually put both x label and y label. So what this is actually saying is that on this end, and let me just get a pointer right here, on this end of the spectrum, or of the algorithm or relationship, if you will, the farming activity is going to be max, but there's literally going to be yielding no crops at this end. Now this end, at the extreme, there is no farming activity, yet the crops are at their maximum value, because basically all the work is being done at this end, all the tilling and the everything, all the work that goes into the land, the seeding, the fertilization, and the development of the crops. Now there's basically you do that, and you do have a little activity as time progresses, but the actual excavation of the land and prepping the land and seeding is where most of the work is. Everything else is just basically waiting around for the crops. I know you worry about things like rodents, and you worry about getting it irrigated and keeping disease away, but that's post work. All that is post effort. And then when they are grown, you just simply enjoy the crops, and there's not a lot of other work and effort to speak about. Now let's talk about the concept of the bar chart versus the histogram. Histograms and bar charts both use column type displays. Okay, so they're both columnar format, kind of like the 80-20 rule. Okay, the 80-20 rule says essentially 20% of the input is responsible for 80% of the output. That's basically the 80-20 rule. So the bar graph is used to compare discrete or categorical variables in a graphical format. So basically, with a bar chart, you might have different things like 5, 3, 18, and then 1. So these are linear values, and then you can just have a bar chart that compares the values visually right here, and then you can easily see, make decisions based off of that. For example, thinking of cybersecurity, what are the main causes of cybersecurity issues? And you might have training here that's causing 5 of them. You might have, I don't know, a certain app that is installed, maybe a Zoom meeting that was responsible for 1 exploitation. However, you take a look, what's causing the most exploitations? That's this one right here, and you'd want to, for example, focus in on this to remove most of the exploitation. And you might find this is like downloading an attachment that is that would exploit your system. So you'd want to focus on this number right here. That's a bar graph. Histogram depicts the frequency distribution of variables in a data set. Before we move on to the next iteration, I wanted to review the concept of the dictionary. You recall from past videos, a dictionary associates a key, such as A in quotes or B in quotes, to a value, such as the number 1 and the number 2, respectively. So in this case, we can print the dictionary. We can say D1 of A, and we can get the value is 1, and we can do the same thing for B, and that value is 2. We can also put in a new entry into the dictionary. We could say C is equal to 3, and we can print out the entire dictionary right here. We can also say D1 of C is going to be plus equal to 10, and we can run this again, and now we have improved C3 by 10, which is now C of 13. We can say D1.keys, which lists all the keys, and we can do the same thing with values, and that lists the values. And we can also create a list, so we could say my D1 list is going to be, and we can use the list command on D1, D1.keys, which is what we're going to do here. And then we could say my D1 list is going to be A, B, and C. We could do the same thing with values, and my D1 list, and that is equal to 1, 2, and 13. That's about it with your dictionary. I'm just going to say in a nutshell. All right, let's take a look at the next iteration right here. We have import matplotlib.pyplot as PLT, and this time we're going to import the random module, and we're saying x equals 0. Now this is a reference variable because we're running a while loop, and while x is less than 100, we're incrementing it by 1, so we can get as like 99 or 100 iterations, 0 to 99. So that's 100 iterations to run this command, random.choice. And what are we choosing? We're choosing from the board list. Now the board list is the list command to generate the keys from this board. The keys are black, red, 0, and 00. And if we're dealing with a casino, they actually on the roulette board, I believe they actually have 000s in some casinos too. So this would be even more. But you can imagine if you ran a print command for board list, you would just see black, red, 0, and 00. So we're choosing that board list. Now, depending on what we choose, for example, black, we are actually going to increase black by 1. Or if the choice happens to be red, we are increasing that choice by the red by 1, or 0 by 1, and so on and so forth. What we wind up with is basically a board with a randomized amount of value, and that's what we will be using to track the what it looks like, how many reds, reds versus the blacks versus the zeros and double zeros over a span of 100 tries. So let's go ahead and run it and see what we get. Okay, so it looks like we had the most are reds, and the next is black, and that's 0 and 0, 0. So this is what we call a bar chart. And I just wanted to also point out to you the fact that we are running the plt.bar command, and that's basically right here, the .bar, and let me circle it. So this is actually making a bar chart that is depicted right here. However, if we move on, we can actually make a histogram right here, and that shows you basically the same thing. What we do is we take our board and we literally make a list of the board. We actually ask it to please append our results right here, and depending on the results, okay, it shows the histogram of the results right here. So here, black was the most, triple zero was the second, and 0 was the second, 000 was the third amount, and so on and so forth. So this is the syntax right here. So go ahead and try it yourself.